Okay, so I'll talk about briefly the research topics that we are working on, and what is interesting to us, and what are the future research directions that on which we are working. Okay, so agenda for these few slides are like I'll talk about our topics which are interesting to us in the blockchain domain and in IoT domain, and also some specific research problems that we are working on, and we are working on a few proposals on those specific topics in supply chains, and in particularly for perishable supply chains. And then I will show you how this overall research activities are kind of integrated in one picture. Okay, so in blockchains, our main interest is public blockchains. Okay, and the reason for that one is that we, from a researcher point of view, we find that uh, the security problems, the privacy problems, and the interoperability and those problems for public blockchains is much more interesting than any permissioned blockchain or even private blockchains. Okay, so for example, if your network is a private network, then you may not even need a blockchain. And permission blockchain, you also kind of dilutes that trust requirements from between the parties. So if the parties trust each other, then why you actually need a blockchain? So our main focus is on public blockchains, and we also try to create private networks out of public blockchains. So we primarily work on proof of stake or proof of work-based blockchains and proof of anything basically. And we try to create private networks, private blockchain networks from these public blockchains. Okay, so this is the area of research in blockchains that we work on, and we are working on developing on evidence-based blockchains. Okay, so as many of the previous speakers are basically pointed out that blockchain's ability is that whatever data you put on the blockchains, that will not be overwritten. Okay, so you cannot easily manipulate with that data. That doesn't necessarily mean that the data is correct. Okay, so there is a difference between uh, whether this data is correct or not, or whether this data is manipulated or not. Okay, so our research is now on developing an evidence-based model of public blockchains, where we will say that instead of having only as miners, we will be able to, the users, basically the peers will be able to select the experts. Experts will be able to provide evidence on the validity of a transaction. So it's like you can create a competition among the validators to prove or disprove some transactions, and that proof will be backed up by the data that is provided by those validators. And those validators can collect those data by using some IoT networks or some other available public oracles, other available publicly trusted data sources. Okay, so and basis of this work is we are using something called multi-agent argumentation. So this has been already a well research area for last few decades in artificial intelligence, particularly in the domain of intelligent agents, where a bunch of autonomous agents basically try to prove or disprove something. Okay, so there is a lot of theoretical work on this side, and we are trying to bridge between blockchains and this autonomous argumentation to come up with an evidence-based model of blockchains. And apart from that, we are also interested into working on the voting models. So uh, as we can have seen that all the blockchain promises is that if majority is honest, so majority means that if more than 50% of the miners, if they are honest, then you cannot manipulate the data. But this is not exactly the case, because we have already seen some cyber attacks on blockchain systems which can be executed without 50% majority. So without the 50% computation power of the entire blockchain network, you can actually successfully attack some of the public blockchains, and it has been done before. So one of the ways to prevent that is to look for alternate voting models, so alternate ways to aggregate the preferences of the miners. So that is another idea that we are looking into. And next is that we primarily work on public blockchain scalability side. So one of our research area is on offline channels, where we are primarily working on Bitcoin network and Bitcoin networks, in particular Lightning network. So these are the offline channels which improves the scalability of the blockchains by not recording too many transactions in the blockchain networks. Okay, so that is why this can be highly scalable, and this can also reduce the high amount of energy uses by some of these public blockchain networks. And we are actively working on developing kinds of optimized offline channel networks. We are working on how we can transfer funds quickly, how we can transfer tokens quickly through these offline networks. And we are also looking into improving privacy and security of this offline network. So these are the next generation of blockchain networks. So these are next generation of public blockchains, and we are working on improving their privacy, security, and efficiency. Next, we work on interoperability side of the blockchain. Now, interoperability, by here I mean the interoperability of the protocols. Okay, so this is not the data interoperability that some of our previous speakers were talking about. So we are mainly interested into how one blockchain, one consensus protocol can talk with another consensus protocols. Okay, so right now we did some research on primarily on the sidechain based interoperability. So sidechains, what it allows is that if you have a main blockchain networks, then that let you to create smaller chains. So smaller, it can be let's say customized blockchains, customized tokens, and things like that. But that is all dependent on a main blockchain network. So that's main blockchain. It can be Bitcoin or Ethereum, and you will create your own tokens in the sidechains. Okay. So we are working on developing high scale solutions for creating these side chains. And particularly, we are working on creating side chains for offline channels. So we are working on how channels that is part of the side chains can interact with each other. So that's in that way we are also trying to improve the scalability of public blockchains. And apart from this public blockchain, this works, we are also interested into some of our applications. So Vistamilk is one of our research centers, but we are also part of other SFI funded research centers. And in one of those research centers, we work with social media. So we are working with particularly with decentralized social media and how we can use blockchains to create decentralized social media, and things like how we can use blockchains to content vetting. So how we can check whether some news article is called right or wrong. Yeah, and we can use the same tools to run some electronic voting mechanisms there. We can use the similar tools for crowdsourcing or crowd sensing over social networks. So all these platforms, this can be built using blockchains, and particularly these are the applications of the public blockchains. Next, we are also working on some combinations of blockchains and IoT, and I will just talk about them. So primarily, we are working on a few topics in IoT, and the first topic that we do research on is on public key infrastructure-based identity management, where the identity is basically your public key, and you can prove your identity by using by proving that you own that corresponding private key. So the challenge here is that we are in a process of developing a decentralized PKI infrastructure using blockchains, which will be much more secure than the existing PKI infrastructure. So, for example, you can the common use of PKI based means public key infrastructure based identity management solutions are probably the HTTPS protocol, where you can trust a website that what it is, by just if it is showing that symbol HTTPS. So that means that it is using actually a PKI-based identity management solution. Now, in a centralized system, these things are done by a certificate authority, which is a centralized entity. And there has been many instances where this centralized authority will face a cyber attack to override some of this information. So lot of the cyber attacks that can be carried out by attacking that centralized entity who controls this PKI-based identity information. And in this research, what we are trying to do is to develop a decentralized identity management solution, which will be much more secure than centralized certification authorities. Next, we are working with credential management for IoT. So there are a lot of opportunities here to develop these credential services, and particularly we are working on developing certification services. So we are working on token-based certification services which can prove any sort of credential. So for example, that I can prove using the token-based service, I can prove that I graduated from this universities, my grades are this and that. So all this credential information can be tokenized and can be presented in a high-scale platform using blockchains. And this is one of our active research areas. And we are working also with some of the research proposals on this domain. Next area in IoT that we are working on is called social Internet of Things. So social Internet of Things are mainly your household devices that are near with each other, that they can form a social network among themselves. So it can be that devices are owned by the same owner, or their owners are neighbors in a social networks, or it can be even they have the same manufacturer, or they are closely located. So there are a lot of dimensions to create this social network, a lot of features to create this social network among this Internet of Things. So what it does is that there can be a lot of services that can be based on the social Internet of Things. For example, mainly some of these devices can provide data, so information on a specific location of a city. So how these devices can securely transfer data from each other, that is supported by the social Internet of Things platforms. Okay, so right now these platforms are centralized, where these devices basically register to a centralized platforms, and it forms its social neighborhood. So it finds other devices that is within its social neighborhood, and it advertises what services it can provide. So what we are doing, we are trying to develop a decentralized social Internet of platforms, Internet of Things platforms, where we solve a lot of security and privacy issues with centralized social Internet of Things platforms. Okay. So next research area, we do a lot of work with cyber security problems for Internet of Things, and particularly there are identity management problems with IoTs, which I already talked about, and we are trying to use decentralized PKI-based identity management solutions for IoTs. We also developed access control protocols, things like equivalent to OAuth. Okay, how we can have a decentralized OAuth. So we already investigated those issues on how to provide a better cybersecurity solutions for Internet of Things in a decentralized way. So this is another area that we work on. And in particular with supply chains, we use blockchains. We previously used blockchains for decentralized serialization. So one of the issues we found with the serialization is that the serial numbers, it can be stolen. It can be printed few times on counterfeit products. So the challenge here is that how we can find and identify that the serial numbers are copied. Okay, so how you can protect the uniqueness of the serial numbers. So we developed solutions which can prevent stealing the serial numbers. Okay, so we have solutions which will prevent an attacker to steal serial numbers and to put it on a counterfeit products. And we also developed algorithms for fast search algorithms to search over the transaction records to find if the same serial number is used in some other product. So we can prove the uniqueness of serial numbers, and by doing that, we can develop a secure and decentralized serialization platforms. Next area that we are working on supply chain management is called is product recall. So product recall is a very common event, particularly in food supply chains, and The main issue with product recalls, what we as an ICT scientist we feel like is that scalability of the problem. So scalability, and there will be a lot of privacy issues. Okay, so we try to we are working on developing algorithms to identify product recalls, and the output of that algorithm is to identify the products that will be recalled at a very high scale. So efficiency is a is the most important parameter there, and then also there is a problem of privacy. So this product may have gone through the various number of retailers, and how we can do this recall process by with a in a privacy preserving settings. So privacy and scalability are the major issues here, and we use particularly blockchain offline channels to run these algorithms to improve its scalability. Next is coordination. We are working with automated inventory management solutions. So we are working with solutions like a bunch of retailers are using, let's say, a product supplied by the same manufacturer, how they can, coordinate their stock levels in a privacy preserving manners, and how they can coordinate their inventory management plans. Uh, while not revealing the data to each other. So we are again using offline channel based solutions there on how to execute these algorithms in a privacy preserving way. Okay, and finally we are working on one proposal there. This is one new proposal that we are currently working on. This is on food waste reduction. So we are working on dynamic supply chain networks. So for example, we are working on IoT devices that is basically labeled, that is stick with the food products that is in the distribution lines, and that sensors are giving us the real-time quality information on the product, and using that real-time quality informations, we are redesigning the supply chain network at the runtime. So basically, it means that if you can detect that some product is originally planned to be in the distribution lines for next 5 days, and we have the real-time information that this product will not last more than 3 days, then we will change the plan and we will ship this product to our retailers that is close by, and they can. So the main objective here is to sell the product before its expiry date, and we take those decisions automatically, and we execute those algorithms by the sensor data, which can give us this the real-time product decay information. So these are the algorithms that we run on blockchains, and in particularly some of these algorithms uses offline channels networks there, and these are despite using public blockchains, these algorithms are highly scalable and secure. So in another research area of food waste reductions, we are also looking into dynamic pricing of perishable food products. Okay, so we have again the real-time sensor information on the product decay information, and based on that, we are coming up with dynamic discount information on the perishable food products. So our main objective here is to have the transparency that once a customer buys a food products, how much nutritional value that the consumer will get, and also there is a fairness in terms of the discount that the consumer will receive. And the main objective here is to is to come up with this discount algorithm, is to encourage the consumers to buy and consume the product before it is expired. So ultimate goal here is to reduce food waste. Okay, so how we can sell a product before its expiry date. So these are the problems with mainly with food supply chains that we are interested in, and we execute. We have developed short-term prototypes of all these some of these solutions, and we also use simulations of blockchains and simulation of supply chains to verify some of these solutions. So overall, these are the research areas that we work with. We work with some fundamental problems with public blockchains, and these are mainly the scalability problems of public blockchains. And then we develop some customized blockchains that is suitable for food supply chains, and that is the evidence-based blockchains, where validity of transactions is mainly, it can be dynamic and it can be supported by evidences. These evidences can be supplied by some sort of experts, or it can be automatically generated by some IoT networks. And then we also work with combination of IoTs and blockchains for food supply chains, and mainly we work with serialization part on how we can have a decentralized and secure serialization platforms. And then for the optimization part of perishable food supply chains, we mainly work with how we can sell a food product before it is expired, either by providing it at some sort of a dynamic discount on the food product, or by dynamically redesigning the supply chain network itself. And ultimately, our main goal is to develop public blockchains that is evidence based, where third party experts can provide their evidences to verify the transaction. So those evidences can be some sort of testing through by some labs, or it can be some other crowdsourced data, and other forms of forensic data. So that is our ultimate goal, is to develop an evidence-based blockchains that can support the food supply chains, where the blockchain does not only take care of the immutability of the data, but it can also, to some extent, say that the data that is entered in the blockchain was correct, or in fact it is correct and it is backed up by some expert opinions. So that is our ultimate goal. And these are the summary of our research activities. That's all from my side. Thank you.
Thanks very much, Subhasis. It's great to get an overview of all of the different areas that you're working in. And I've seen a Best Student Paper award there at the end as well. So very, very well done.